So welcome to CS3 2023. It's really a great pleasure to see you all here. Many familiar faces and also many new faces. It's really great. And, you know, it's been a while we last met. And that while lasted more than 3 years. So this is a conference with history. It's the 9th edition. We started in 2014 in Geneva, and then we traveled through some beautiful European cities, eventually to end up in the lockdown and having to do 2 virtual events. But even after these 3 years, more than 3 years, 3 years and 1 month and 1 week, to be more precise, it's really great to be back all together in person, because I think this is one of the great values of this gathering. Not only the excellent technical content and the scientific content of the conference and the presentations, but also opportunity for all of us to discuss during the coffee breaks. There's going to be a reception tonight, and reconnect with the community. And I think this is what we have really been missing for this last 3 years of the pandemic mode of operation, which is essentially just remote conferencing. So I'm really happy. I'm really happy to meet in person in this nice venue. Big thanks to ESADE, who is our local organizer and partner, for organizing this very nice venue and taking care of all the logistics. So, as I said, this is the first in-person event after the pandemic. So we have 120 on-site participants and 30 plus remote participants. This number is still growing. We essentially wanted everybody to come on site, but as you know, it's becoming harder to travel for various reasons. So we also opened this last-minute possibility for our colleagues to join remotely. And there's many people from the community that participated in person that will also connect remotely in the previous events, which will also connect remotely to this event. So to be honest, I was quite puzzled, or actually interested / worried, how many people after these 3 years, what is left of this community. Because, well, I think for this kind of endeavors and collaborations, like in the research and education space on technology and so on, in-person meetings are an essential component. And I'm very happy to see that actually our numbers are actually corresponding to what we had seen in the pre-pandemic times. So I did a quick calculation on average in the last 3 pre-pandemic events. So 2018 and 2020, we had roughly 130 participants on site. Now we are 120 plus 30 plus remote participants. So I think it's very nice. It's also a testimony to the fact that this community is alive and kicking, and there is still interest in these things, and everybody is motivated in participating in this community and pushing the boundaries of our collaborations forward. Again, we have large institutional diversity as usual during the CS3. So you have universities, international organizations, NRENs, computing centers, private companies, SMEs, and some enterprises, European Commission, and so on. So I think this is also another outstanding aspect of this. We have a rather informal setting where we can discuss and really do a lot of kind of discussions in a very informal setting, as I said, and at the same time, it's kind of a very broad spectrum of institutions and with different backgrounds. Also, large geographical diversity. So the event, the participation is dominated by European participants, which is not very surprising, but we also have guests from Brazil, China, United States. So this is really nice. So this is really a global community. Very quickly, this is a small recap of the evolution of the focus areas for the last 9 editions. And of course, you know, from the beginnings where we were focusing on actually discovering that everybody is doing something similar and maybe it's interesting to come together through various phases of different topics that we developed. So I'd perhaps like to focus on the last 3, so 2019, 2020, and 21, 22. I think these topics are still very much present in the agenda of this event. So integration of storage, sync and share services into the research environment for analysis, for open data, open science, federations and interoperability. This is another big theme. As we know, that was always a highlight of our collaboration. So open cloud mesh, now ScienceMesh, HiFIS, and some other examples of institutions that are looking into federating their services. So this is also an opportunity to discuss on future storage concepts, development, and the collaborations for open science, research cloud, European open science cloud, and so on. So I think this event is really about coming back together, looking into what we have been doing through this last 3 years of pandemic, understanding this landscape, and then seeing if we can consolidate some efforts and look for future opportunities. So program highlights. I think it's our tradition to have an incredibly packed agenda, timetable. So we have many presentations during the 3 days. We also have 2 very exciting keynotes, one from Professor Alfonso Valencia from the Barcelona Supercomputing Center on the technical and scientific challenges in biomedicine from a European perspective. So this is this morning. And then tomorrow morning from Professor Barend Mons, who is one of the founders of the idea of the FAIR principles in on a very interesting topic for the conference, which is about sharing with the title Stop Data Sharing. So I'm looking into this keynote as well. So some other highlights, there's going to be discussion on standards and interoperability tomorrow afternoon. So OCM 3.3 APIs, status, governance, and collaboration. And also, I think something that everybody is interested in is the interoperability of our EFSS platforms. Also, tomorrow afternoon, a demo session on ScienceMesh with some discussion on how to join this federation of sites and services and how this can benefit your service and your organization. And we also do have on a Wednesday afternoon a co-located meeting, which is SIGKIS. This is a special interest group from Jong on cloud infrastructure services, platforms, and workflows. And if you would like to participate in this workshop, you are welcome to contact Mario Reale. Mario so Mario is here. So if you'd like to participate to this session, yeah, it's okay. So Mario tells me it's open. So if you'd like to participate, you're very welcome. Okay. So very quick recap of our site report survey will be presented by T-Law this afternoon during the site report session. So ETH is maintaining a community map of services for file sync and share. And we also do as you know, we also have a survey. So sites are essentially providing updated information. So this is a picture of the community that we try to give you. So Tilo will summarize this, and there will also be a couple of highlights of dedicated site reports. One special mention. So this event is supported by the CS3MESH4EOSC project. The project essentially sponsored part of the early fee discount, because we understand that there is, it's harder and harder to travel for people because institutions are trying to save on travel budgets and so on and so on. So we thought that this is important to make it easier for people to travel, and this is why we decided to sponsor that part. But also the project, let's say, supports some other community initiatives and activities with an idea of, how essentially look out for how to increase the value of EFSS services. So the services that many of you are running, supporting interoperability initiatives such as ACM, and looking into the ways how we can consolidate and preserve technical contributions from the community. And last but not least, making CS3 community a visible and substantial component of the research and infrastructure landscape in Europe and beyond. So that's about the support. So organizing a program committee. So it's been hard work of many people, and I'm very grateful to all of them because they do it purely on voluntary basis in addition to their daily jobs. This is the program committee. You will recognize the program committee and the organizers with the white lanyards. So if you're having a question or want to connect to this committee members, you look for people with white lanyards like mine. So everybody has been contributing in many different ways. I would like nonetheless give special mention to Gideon, who is probably not here because actually he is very busy looking after all the other logistical details. But Gideon has been really making sure that all logistical details are handled, and he's put a lot of additional work into this. We will run as usual a survey on the conference feedback. This is not yet enabled in Indico, but we'll send you a message when it is. And we would like to hear your feedback on this event. And please help us to improve CS3 conferences. This is a community event, and actually, we take this feedback very seriously. So a couple of years ago, when there was a particularly cold winter, and we did this conference as usual in January in the Northern Europe, there was a very strong feedback in this form that we should do something about it. So here we are in Barcelona in March, okay? So it works. So give your feedback. Right. So a couple of screenshots from the last events. This is what I'm looking for. Also here we have an absolutely fantastic venue and everything necessary to have an excellent workshop. As you have seen in the lobby area, there's also the areas where companies have their tables. So you can also it's always been designed like this in order to promote a little bit the interactions of the community with the participating companies. And we will be updating you with the logistics details about lunch, which is, I think, in another building, but it's not very far from here, and all the rest as we go. Okay, so this conference is recorded and streamed on Zoom for registered remote participants. the remote participation is not completely open. We vet the registrations because, you know, in this new world of everybody going remote, there's many people who maybe not necessarily are part of the community that try to join for different purposes. But nonetheless, be aware that this is recorded and streamed on the internet, and that the recordings will be published after the conference. So if you have any questions or concerns about the privacy, please reach out to us, the program committee. Again, big thanks to our local organizers, Zade, for hosting us.
My co-workers, in a way, one of them actually from SUNET, another one from Westfälische Wilhelms-Universität Münster, Juri and Richard, both on the topic of how do you do FAIR inside of these sync and share systems, the Sciebo RDS system. Come up. Mic here and mic there. Do you want to be mic'd up?
I'll try this one. Yeah, I didn't expect to talk right after you. So if I had, I'm not sure I would have dared to use the term FAIR in the title, but the title is Sciebo RDS, Reducing Friction of FAIR Data Handling for Researchers. Is this the... Okay, so short introduction. You already know Richard from yesterday, where he introduced SUNET Drive. I'm Juri Hößelbarth. I work for the University of Münster. Short background, it's basically a recap of what we already had yesterday. So the University of Münster is a major German university with a lot of students, and we run Sciebo, which is a big sync and share service for about 40 universities in Germany. Yeah, do you want me to do the...
Just to the bullet points. Yeah, so the Swedish University Network is the entity handling a lot of infrastructure in Sweden, founded in the 80s as a research project. They like to dig trenches and put fiber cables in it, so they have about 8,400 kilometers, serving 750,000 users. As I said, lots of infrastructure. The SUNET Drive that we have is based on Nextcloud 25, federated sync and share. We currently have about 2,000 users, but system is built for all 54 universities / identity providers we have, and we have 2 petabyte available, and it's getting some traction right now. We have about 120 terabytes in it and get half a terabyte every day into the system. One thing I always like to point out is that North Rhine-Westphalia is about 60% bigger than Sweden population-wise. So that also gives you a bit of a relation between those 2 systems that we're handling.
Gives a bit of perspective. Okay, so to introduce Sciebo RDS, the use case. Imagine you are the provider of a big file storage that serves universities and educational institutes, and you want these people, or the people that use the service to work on their data in this sync and share system, and they want to publish their data one day, or at least you want them to publish their data. So currently it would, actually, let me skip. Currently this would be, they would have to sync their data from the sync and share service to their local computer, which they're probably doing anyway, but after that they are kind of switching context. They maybe get another tool to annotate the data with metadata, and from there, when the project is finished, they have to upload to, for example, Zenodo or OSF or whatever repository they want to use to archive their data. So that's pretty cumbersome, right? What we actually would want, and that's what I skipped here, is just to export from the file storage to the repository. And that's what we are trying to do here. So Sciebo RDS is basically a middleware between a host that's an EFSS system and, for example, research data repositories or other places where you want to archive your data. Actually, So we do metadata annotation via a tool called Sciebo, which uses RO crates, if you're familiar with that in the background. It's a standard, I think a pretty new standard based on JSON LD. It integrates into an EFSS by the native plugin system of the EFSS. And it's basically a wrapper around a standalone web app that's the core RDS. It uses basic EFSS functionality. So if you want to integrate it into an EFSS, you need things like file pickers and OAuth user management. And each storage provider and repository. So basically, the part you see on the right here in the graphic is implemented as its own microservice, which makes it quite extendable for your own EFSS by just writing the native wrapper plugin to work with your EFSS system. And it also makes it easily extendable for your data repository by just writing a microservice that integrates and maps to your API. So here's a schematic of that. You see, if you would want to integrate Sciebo RDS into a new EFSS, you would have to write the wrapper plugin, which is integrated here in the EFSS. That talks or basically integrates the RDS front end as an iframe, and the whole RDS core then again speaks to the microservices that map to the repository APIs. And if you would want to integrate a new repository, or you have an internal repository at your institution, that's what you would have to write to get Sciebo RDS to talk to it. This is a short demo. I'll try to commentate what's happening. I'm not sure if it's manageable. So we see here we have a data set within Sciebo. Sciebo is, as we know, own cloud-based. We open an app. We have here the list of connected repositories. We choose possible repositories. We choose to connect to Open Science Framework via OAuth. We choose a folder within our EFSS storage. We choose a name for the project, and we also choose where we want to export it to. This is our current metadata annotation tool. You can see you can have arbitrary metadata profiles. This one is just a profile that maps to the OSF API by mapping the title, the category, and the description. Now we can see the Sciebo has actually written back an RO crate metadata file to the file system. And now we click on publish, wait some time. And now it says the project was published. We switch to our OSF dashboard, but we didn't have a project yet. But now we see we have a project. It has the title, the description, and the category we gave it. And it also already has an identifier. We have all the files that we had in the folder. And here you see in the recent activity tab, you can basically see all the different API calls that RDS did to publish the project. Okay, that's it for the demo. For development, we at the University of Münster developed the basic RDS core. That means if you still remember the graphics I had just a few slides ago, the middle part, we do the own cloud plugin because we use OC10 for the Sciebo. That's a wrapper plugin. We also develop the connectors for Zenodo, Open Science Framework, and WWU DataSafe, which is our internal service. We have partners like SUNET, SND, and SURF that have adapted or are in the process of adapting Sciebo RDS for their own use. For example, SUNET ported our own cloud plugin to Nextcloud. SND, the Swedish National Data Service, is in the process of writing a connector for their own repository, their internal repository called Doris. SURF did a Figshare connector and a Harvard Dataverse connector. Everything's openly available on GitHub. Everyone can write their own connector or EFSS plugin. We have an extra repository for third-party plugins, connectors. Yeah.
Yeah, we'll just quickly talk about porting Sciebo to Nextcloud, and that's maybe also linked to C-File. Maybe they're listening that this is actually a good, valuable academic toolbox that is being developed here. So you need to build your own infrastructure. I mean, we could think about having common infrastructure, of course, but deploying it yourself is always a good thing. So we had a good workshop with them where we streamlined the whole infrastructure setup, setting up the Helm charts. If you saw Marcel's presentation yesterday, that helped quite a lot, setting up everything. And then the RDS app needed to be ported to Nextcloud. There were some smaller changes necessary within Nextcloud, but these were more or less minor things that were accelerated by having a good workshop together. And then, as Juri already said, we have this SND, Swedish National Data Service, Doris connector, where we're in the process of actually developing the connector, defining the architecture design, and specifying how the actual integration looks like. And this is a bit the architecture of Doris. So it's a metadata management system, which is cross-discipline, and it's a heavy use of controlled vocabularies. And it's a bit of a paradigm change compared to the other publication tools because we want to retain the S3 storage ourselves in the file storage system and only publish the metadata and link back to the published data. That removes even one more obstacle, especially when you handle large data sets that you only publish linked data and have a public URL that's then handled by the metadata system SND Doris. This is just a quick demonstration. Let's see if that video actually works on publication from Nextcloud. It's work in progress, but I think the video is not starting. So you just have to believe that it's, okay, I had to press next. Now it's working. So that's now the publication example to the Zenodo sandbox from Nextcloud, exactly same environment. So even if you switch universities, you will get a familiar interface for publishing your research data, which I think is quite a convenient thing.
I think actually the RDS instance that you are seeing here in the Nextcloud is the same one we use in the own cloud. So it's pretty agnostic.
Yes, and that was our quick talk about beta data management, fair handling.
Thanks for making good time. I'll allow a short question if anybody has one. Eeny, meeny, miny, mo. Sorry.
Thank you. My little question is only, once you have exported the files, does the EFSS system get some information back in order to be able to display that this file was once
well, of course, that's different for different. Basically, you would have to implement that in the connector, right? Because RDS doesn't know about the API of the specific repository. So whoever is developing the connector would have to basically collect the responses.
And is it already part of the RDS then?
Sorry?
Is that already part of the RDS already?
I think for example, for OSF, we get the project ID back, but we don't collect things like comments or citations or so yet. But that's definitely a use case and something for the future.
Okay, thanks.
Talking about the interoperable federation of EFSS services on behalf of the ScienceMesh project. So again, I shouldn't praise you more because then I'm praising myself, which I don't like to do. You mic'd up?
I believe so.
Can you guys hear me? Yeah.
Perfect.
Oh, okay, can hear myself. Yeah, perfect. Thank you very much. Okay, that direction. Okay. So last talk before lunch break, right? Is that it? Yeah. Okay. Okay. Thank you very much. I really thank the organizing committee for this. So I'll be talking to you about the ScienceMesh. What is a ScienceMesh? The ScienceMesh is the main deliverable, main result coming from the CS3MESH4EOSC project. So if this thing works, yeah, this is a project which brings together 13 partners. They are listed here. You probably know them. Most of them have already spoken at this conference in some form, so I won't get into that. But since CS3MESH4EOSC, which is the original name of the project, was too hard to pronounce, an acronym that doesn't really stick, we decided to place all the work that we produced under the umbrella of what we call the ScienceMesh. So the ScienceMesh is a decentralized mesh of enterprise file sync and share nodes, and is something that was born from our community, from our CS3 community. It's made mostly of organizations that were already members of this community. And of course, our hope is that it will gradually increase and become an even greater subset of this community. It's based on open standards and open source software, like most of the things we do in this community. The goal stated in this project, and also because of the connection to the EOSC, that it's kind of subjacent to the project, is to create a federated research space for Europe and an interoperability platform to develop and connect new applications on top of it. So I will do a bit of an exercise in topology and try to define the ScienceMesh in 3 dimensions. So the first dimension being a trust-based federation. And we very often get the question, which is, okay, what is it that you guys are doing that differs from OCM? And the answer is, well, nothing. OCM is actually one of the technologies that are basically subjacent to the design of the ScienceMesh. As you know, OCM allows for a common file access layer which can span across organizations. It's a standard that is implemented by OnCloud, Nextcloud, and C-File, and it's something that perfectly allows you to communicate, one-to-one, so to say, between nodes. If you know the identity of the person in the target system, you can basically establish a share with them. And this is where the ScienceMesh comes in. We try to complement OCM by adding a discovery mechanism on top of it. So actually, we add a few other things that I'm going to mention in a minute, but this is let's say the main selling point. So let's imagine there's me at CERN and there's Ron at SURF. Well, he's actually sitting there, but let's pretend, just for the sake of the exercise. I'll send Ron an invite link. I'd like to connect with him, so I send him a link via email, via instant messaging, WhatsApp, wherever. He will visit the link, and the link will bring him to something which is called the mesh directory. So this is basically a catalog of all the mesh nodes, and Ron will pick his home node from the list. So it's basically we've just spoken about it. Where are you from? And this where are you from page is basically going to take you to your home authentication system, in this case, SURF's own authentication. After that, you will be redirected to SURF drive, and the information will be relayed that basically says, okay, I check that this is Ron, this person who's trying to do this is Ron, and he has accepted to connect with Pedro, and this is Pedro's identity, and he's located in the SUNBox server. So from this moment on, SURFdrive and SUNBox, they know both of them, that Ron is located in SURFdrive, Pedro is located in SUNBox, and they can then establish a direct connection between these two users. And this is then where OCM kicks in and allows the magic to happen. So I'm happy to say that we have already implementations of this mechanism in Nextcloud, on Cloud 10, and also OCIS. And that's actually going to be the object of a demo in the afternoon. So I'm already, trying to promote our ScienceMesh session in the afternoon. So if you're interested, just tune in. Michiel, Milan, and Lisa are going to be showing you a little bit more about it. These are just some screenshots from the interfaces, but really just come to the session. So, and this is the mesh directory interface I was talking about before, which was developed by our colleagues at JESNet. So the second dimension is an application platform. So I'm going to complexify a little bit again this geometrical metaphor, and add this three-layer structure that defines the ScienceMesh with the sync and share system at the bottom. Then the middle layer is what I've just mentioned, so the federation and the interoperability platform that established the basis for then a third layer of application and research services which work on top of it. And we have classified these services in 4 areas: data science environments, open data systems, collaborative documents, and on-demand large data set transfers. So I'll go over each one of them very quickly. So the data science environment cluster, in this, the main application that we've developed in this context was the plugin for JupyterLab, which allows you to share notebooks across users and then collaborate in data analysis. You can basically grab federated resources from other nodes and use them in your analysis, and then do concurrent editing. So Marcin is going to be doing a demo of this in the afternoon. Then we've got the second cluster of prototypes we've developed, in which I'd like to highlight the open data workflow, which has already been presented by Juri and Richard. So I don't think I can add much more to that really great presentation. But just to say, yeah, the main goal is to generate fair data from non-structured data, unstructured data, which is located within the EFSS, and it's based on really known tools like Zenodo and well, Zenodo is one of the target systems, and OSF as well, but also the Sciebo, which was already something pre-existing, as well as Sciebo RDS. So we've thanks to the project, we contributed to the further development of these tools and brought them into the mesh and integrated them into our own tool set. And it's already deployed at some of our sites. So you've seen the presentation earlier. The third cluster I'd like to mention is so collaborative applications, and in this particular one, I'd like to highlight the Markdown editor, which is basically based on CodeMD, which is many of you probably know it. A collaborative Markdown editor allows for live editing, and there's going to be a demo by Giuseppe at 4:30. There's a presentation on this, and she's going to show you how this works. But basically, this allows you to use CodeMD from your sync and share system. And we're already using it actively. And at this conference, for the the notes for I mean this little document in which the people who are currently on Zoom, where they can submit their questions, this is already using this mechanism. And the last but not least, the data transfers cluster. So in this regard, we have a couple of, actually even 3 prototypes that we have developed within this field. So the main use case is, LOFAR and the transfer of large volumes of data between sites in LOFAR. But so we have a point-to-point prototype. So let's say an ARC-clone-based solution, which allows for point-to-point transfer of files between users located in different nodes of the mesh. Proof of concept, which was successful, and we're currently working on a user interface, which allows us to use this directly from the EFSS. But we have also transfers between VOs, and it's going to be actually the object of a demo that Ron is going to do in the afternoon during the ScienceMesh session, in which he's going to show you how you can transfer data from FTS to your EFSS through the interoperability platform. And there's also same thing for Ruscio, which is currently in the works. And we come to the last dimension, which is the connector of federations. So ScienceMesh is a connector of federations. So ScienceMesh can be defined as a sort of loose federation based in a trust, a model based on trust, which is established through this invitation workflow, which I've shown you before. But we also allow for the existence of nodes, which will let us communicate with other federations and establish relationships with other federations outside our field. So one such example is the work on integration with EGI that has been developed by our colleagues at SUNET, and which allows ScienceMesh users to use EGI services thanks to cross-authentication happening between the 2 infrastructures. So that's indeed very interesting. We're also working on looking into ways to bring these into EOSC, which is an integral part of the project. We've already discussed before that there are different opinions as to what EOSC might or might not be. We have a vision for it, and we're trying also to bring that vision, or we have vision, let's say, for a part of it, and we are trying to bring that vision and to realize that vision and to contribute to this effort with what we've already developed. So we hope that we will have more news in the future. So let's just at this point see where we are, try to establish the situation. We have a test bed which is currently running, connecting 8 sites. This is something which has been already established since a few months, but now the news is that we have also a pre-production setup which is connecting already a few of our sites. Last time I counted it was 3, but it's possible it might have changed in the last few days because we're really accelerating this effort. And this means that these sites on here are already using real, user identities, and real users can have already access to it through their through their local authentication systems. So what will we be doing now? We are currently working on establishing the official mesh bodies. This is something we'll be doing at the workshop, which will happen on Thursday and Friday, an internal project workshop. So we're going to be staying a bit longer in Barcelona and enjoying the good weather, which apparently will follow. And part of that work would also be perfecting documentation. We have quite some more still to do with user interfaces. We have already many usable interfaces, but there's still some polishing required, some improvements, some user experience details that have to be taken care of. And of course, we are starting to onboard more nodes. Yeah, there are already 2 nodes from outside the consortium, and there's another one which is about to join. And of course, the main goal is to move to production. And right now, we're trying to move as many nodes as possible from the test bed to the QA, the pre-production setup. So this is the project website where you can find general information about the platform, as well as an application catalog, a little bit more information on what I've just mentioned. And this brings me to my summary of this presentation. So It's been already 3.5 years of project, which are now reaching the end. We finished the CS3MESH4EOSC project will officially end in June. But as you can see, there have already been lots of new developments. We're starting to see really what we had, hoped for, becoming reality. There's already plenty of usable interfaces, deployable applications can be used. We're at this moment just fitting, the bits and pieces together to finally get to production. There are already applications for Nextcloud and on-cloud. Actually, integration with the main vendor platforms is, as we speak, really happening, and there are new developments basically every hour. So maybe you will hear some more news on that soon. As I said, there are already 11 nodes, 8 plus 3, 2 of them from outside the consortium, more on the way, and some of our users can already use these directly through our own authentication infrastructures through our QA setups. We are aiming at production in summer. And well, if you want to know more about it, and I hope so, just join the session in the afternoon to see the nice shiny demos. And I think that concludes my presentation. So hope to see you later today. Please go ahead.
Thank you. So yeah, we started PondusFirst 2 years ago as with our sort of launching project of integrating ScienceMesh with Nextcloud and OC10. And I'll try to tell you a bit about our journey of the past 2 years working on that, and mainly about everything we learned about, like if you have, you can build something, like if you build a car, but then you want to drive a car on a road where there are other cars. There are a lot of extra things you need to take into consideration before that is actually safe and is going to work without your car breaking down. So in theory and practice are the same, but in practice, they are not. And this is a wall in the SURF office in Utrecht that I pass every morning in when I work there. And it's a good reminder of making sure that you don't just implement the happy path, but also implement error checking. And yesterday at dinner, Fergus said, like, wouldn't it be cool if somebody would just go on stage and say, actually, yeah, I tried something and it didn't really work the way I wanted. So yeah, in this case, if I do it again, I would not start with a happy path. I would start with the error checking, and then it would have been faster to get where we are now. But anyway, we did the happy path first, and then we did the error checking, and now we're at a point where everything works. So having said that, the advantages of ScienceMesh, just to recap again from Pedro in my own words, there's advantage one is that you get a trust-based federation with those CM invites, because you can do open cloud mesh. That's just saying, okay, I can share with anybody, and it's just like email, and it's open, but that means you get spam. So to have some more of a community-built trust network, ScienceMesh is a better option there. So it's sort of an evolution of the open cloud mesh idea in that sense. So a CS3 community of trust, and that's exactly, it's something that's coming out of this community, and that we as NRENs can build this community of servers that trust each other across Europe. Opaque but discoverable usernames, that is a very cool feature. Like the usernames don't have to be recognizable like an email address. They can be long strings, because we have this way to discover them with display names. And that way you get a sort of an international mesh between enterprise file sync and share systems. So advantage two is you can open a file with an app via Riva. So you can have your files on a file share server, but based on the MIME type, you might want to use a different application to edit that file. And that is the real interoperability platform of the IOP that's behind the idea behind that. So you have an EFSS plus Riva, you put those two next to each other, and then you can add more apps to it. And that's where you have a pluggable system And because everybody will who joins ScienceMesh uses Riva, then this also becomes compatible both Riva to Riva, but also with the applications that you plug into it. And the third advantage is that you can, which Ron will demo in with the LoFar example, you can interconnect storage infrastructures, which is also, I think, a great thing for NRANs, because you a lot of you have big storage infrastructures, and if you can connect those to your EFSS system and do sharing, you can unlock and connect all these big storage infrastructures. So through data transfer. So that way we can get the vision of a CS3 community where all our trusted infrastructures are interconnected. Now, are we live yet? So there's the testnet of ScienceMesh, which you see some dots here, maybe a bit small, but you see this: Denmark, PSNC, CESNet, SURF, Switch, CERN, and these are all connected different deployments. So CERN is OCIS based, and most of the others are either OC10 or Nextcloud based. And here are the instructions of how to integrate. If you're using Nextcloud or OC10, then you can use the link that we developed through these instructions that are on the ScienceMesh.io developer documentation. So we need to do some sort of security review and pen testing before we put this live and let all our researchers and students test it. Some better error tracing, we've done a lot, but we still need to have sort of tracing, because you connect from an EFSS to a Riva to another EFSS that maybe says, oh, file not found, and then it says 500 error, and then this one says unexpected response, and then says gRPC failure, and then the error message is just not traceable to the real. So that's the thing, that if we do it again, we'd start with that, and we're adding that now. Feedback from early adopters, like one thing we immediately found is that the one-way invites are counterintuitive. So we changed them to two-way invites, and that we need a better invite manager where you have sort of your contacts, maybe also integrated with the contacts of your EFSS. And then we need we need to switch it on. So the user backends, a lot of the sites have already used their real IDP backends. Storage backend is a little bit scarier because there's actual files there that need to be protected. And then if you are running your ScienceMesh node on the real infrastructure, you still have to switch it on to actually tell your users in your newsletter, like, hey, there's this new thing now. You can now share things via ScienceMesh. So these are the nodes that we're working with. So actually, and apart from just doing the development, we're also helping these sites to get their site running. There are also some dependencies on OwnCloud and Nextcloud. And nice thing is that the OwnCloud ones was merged yesterday, so we're really happy with that. And if anybody from Nextcloud with committing access is in the room here, look for PR 36228 and maybe just run the test and merge it. So we don't have to use patches, because right now NRANs have to patch their server, and that's not good, because a patched server is harder to update in case of security update. So that's how I see us moving to production together. So it's I think it's really exciting to see how we're moving, working together with all the sites and building this ScienceMesh as a community. Thank you.
Thanks a lot, Michiel. So next up, we're gonna have Milan, who's going to be show us, well, in practice, how invitation workflow, working with OC10 and Nextcloud. How do we want to do? Do you want to presentation? Yeah, there's like short intro. Okay, I'll just share it on Zoom so that the people on remote can also. Okay. And to click next. Yeah. Okay. Just share screen. Here you go. Okay.
Okay, good afternoon. I'm going to demonstrate to you the invitation workflow, which was before lunch introduced by Pedro and partially also by Michiel. So we prepare a short video together with our colleagues from PSNC about invitation workflow, which demonstrate the establishing of the trust between OC OnCloud 10 and Nextcloud. The scenario is very simple, where we have two users, Miroslav from PSNC and me from SUNET, where Miroslav wants to share the data or files with me. But however, Miroslav doesn't have any idea what is my sync and share system. So we will use the invitation workflow where Miroslav will send me the invitation via email. Then I will reveal my identity using the where are you from service. And then Miroslav can start sharing with me. The invitation workflow itself established trust between two users from two different systems connected to the ScienceMesh. The advantage is that we don't need, as the originator of the sharing, you don't need to have the exact knowledge of the target system. You can just generate the invite and send it via any preferable way, chat or email and so on. And the trust relationship could be later reused for sharing other type of resources, not only for files, which is demonstrated now, but also for the other resources which will be demonstrated by the following demos. Okay, so I think we can. Okay, so let's start. So now we are looking at the PSNC Nextcloud instance where Miroslav is logging in via federated identity. So now we see the Nextcloud dashboard where Miroslav is going to upload the cool data sets which wants to be shared. Okay, so now the upload is done. Quick check of the data. Okay, was correct. Yeah. Now we use the ScienceMesh integration application and generate the invite, which will be sent by Miroslav to me. So now copy it. Now Miroslav prepared the email. Very simple way how to share the invitation. So now pasted the some email with the invitation link. Yeah. Now we switch to my inbox at SUNET. So I see that I received some email from Miroslav with the invitation link. So I will click on the link. Now I am being redirected to the mesh directory service, which is the list of sites connected to the ScienceMesh. So I will choose my home sync and share solution, home sync and share system, which is located at SUNET. Yes. And now I can accept the invitation which was sent by Miroslav. Now I will log in into my system. So I will reveal my identity and my target systems. Yeah, so now I accept the invite, so it was successful. And now back to PSNC Nextcloud. Now I appeared in the context of Miroslav. So he will go to the file which he wished to share with me and share it via the knowledge of my identity from Nextcloud. Yeah, now it's already appeared there. So just click. Yeah, and now the files are shared, so I can easily access it from my OnCloud system where I can see the data shared by me and accept or decline the incoming share. So definitely I'm going to accept. And now I can cooperate and process the data shared by Miroslav. So that's all. Thank you for your attention.
Great. Hello, I am Lisa, a front-end developer at CERNBox, and today I will present you yet another OCM invitation and sharing workflow that we tried to make user-friendly. And it's basically the same scenario. Me at CERNBox want to share some data with another person, Albert at Marineford, which is a test instance that is also based on OCIS. And I send the invitation to Albert via email, and he reveals his identity by accepting the invitation. And then we basically have the possibility to mutually share. So now I need to go to the video.
I didn't do anything wrong, I hope. So yeah, you go. Let me just maximize.
Okay. So let's see how it looks like. I want to share data with Albert. And I skip the login. So you saw I wanted to share some data, and I want to send the invitation. For that, we implemented an extension, ScienceMesh extension, that has an overview over all invitations. Here I generate invite token, can put some description to remember for what purpose, put the email and click generate. And we have a mailer that automatically sends the email, and then Albert receives this email. We here created a nice ScienceMesh template for this email. So he follows the link in the email, goes to this central registry, selects his provider. Take some time. Okay, accepts. And with this, he is redirected to his provider with pre-filled fields for this accept form. So he accepts the invitation, and now the trust is basically established. So I am also myself notified when he accepts that I have a new connection. And this connection is also getting highlighted. And now I can go to my files and share basically the folder. Here I select the user type federated, type in his name. Select some access rights for him and share. And he receives the share and basically can browse through it. And we also can collaborate on shares, and that my colleague Giuseppe will show a little bit later. So now I need to go back to the presentation. Okay, so we of course try to make it user-friendly, and in usability study there is a very famous set of rules that you can follow to achieve a better usability, also called 10 heuristics by Nielsen. And I tried to group these 10 heuristics into 4 categories: make it clear for user, make it the interface familiar for user, empower the user, and avoid errors. And I will go a little bit more in detail about these heuristics. So the first one is aesthetic and minimalistic design. We tried to achieve this with this interface. So we have overview over all of your invitation activities in one view, but at the same time, it's clean and not overloaded visually. Of course, another heuristic is consistency. So here we reuse the components that are created by OnCloud with OnCloud design system, where they put a lot of effort to make it user-friendly. So these components are already familiar to users from the OnCloud web. And also another thing to have in mind by consistency is wording, so that we have consistent wordings. For example, we use words like institution instead of provider, which might be maybe not that familiar for the users. For sharing workflow, we seamlessly integrated the sharing workflow into the usual sharing, so users are also familiar with it. Okay, also it's very important that the system shows to you what is going on. And for that, we have on any kinds of interactions of the users, the status notifications. So when you, for example, create a share, it shows you that the share was created and so on. And also some highlights. So whenever, for example, I get a new connection, someone accepted my invitation, there is a notification and a highlight on the table that says you have a new connection. So another important heuristic is mesh between system and the real world. And here it's important to really use users' language and not developers' jargon. When we say to users OCM shares, they will probably not understand what we mean. So we really try to use users' language, also familiar icons. Another important thing is that human beings can easily recognize things, but recall is harder. And that we also try to keep in mind. And for that, we have something not implemented but planned, which is so-called inverted sharing workflow. Because normal workflow nowadays is that you select the files, and then you select people you want to share with. And if you already have these connections, federated connections, of course, we could do the reverse way. So we already have people that we can pre-select and then go to files and select files you want to share with these people. Okay, so another heuristic is flexibility, and we give the users the flexibility to select how to send or accept invitations. For example, you can pull this email, and then we have the system that will send the invitation email to the user, but it's optional. You can also copy the token and just send it on any other way, like Facebook. Also, if you don't have the email for the user and you create the token, it will automatically get copied to your clipboard, so you don't even need to click on copy. Another thing is if you enroll of the invitee and you click on this accept in the central registry, then you are automatically redirected to our application, and the field with accept accept the invitation will be focused. So you don't need to scroll, it will be already done for you. Okay, how can we empower the users? Of course, it's also important to provide help and documentation places, and for this we've foreseen several places like about navigation tab, where we would put the user documentation and also some helps on each of these sections for invitation. Okay, and last but not least, for empowering users, it's important to provide undo actions to give users more control. And we didn't implement it yet, but it's part of the concept to implement the features to remove tokens, connections, and shares. Okay, and of course, the system should try to avoid errors. So the best is to prevent these errors, for example, by validating fields of the forms before submitting. And if the error happens, for example, in the backend, of course, we need to provide meaningful, user-friendly error messages and not some, again, developer jargon messages. Okay, so this was these 10 very famous usability heuristics that we tried to follow. But of course, great user experience is not only usability, you also have aspects like usefulness, and you already have people who explained why it's very useful for people to do this federated sharing. Another important part is accessibility, and here we rely on Cloud's design system components that come with great accessibility features. And another thing, of course, is the findability. So once we will release this feature for our users, we will inform them by some notification that this feature is available. Okay, so what are our plans? Of course, we need to do some UI polishing because the usability is never perfect. There is always something you need to work on. We need to do user tests. We just tested it with some test users, but a proper user test would help to identify some problems. And we need to converge with OnCloud, of course, on the solution. And so we also have an idea, because we could converge with our ScienceMesh community on the concept, basically, of it, because, you know, the invitation workflow is exactly the same for every one of us. So why do we reinvent the wheel? We just saw pretty different solutions. They have some similarities, but also some differences. Maybe we could converge on it. One step further would be, of course, to converge also on the implementation. That would really make it easier for some other providers, service providers, to join ScienceMesh Club, of course. And there are modern technologies, at least from the front-end perspective, that would allow, for example, to have an extension injected into the completely different technology stack. So there are such things, and we could really discuss how to do it, because it would really simplify joining the ScienceMesh Club. Okay, last but not least, I was presenting you our implementation from the front-end perspective, but of course there has been a lot of work done in the backend side. So my colleagues were working a lot on OCM APIs and backend, and Giuseppe will also present a little bit more about it. Thank you very much.
Thank you, Lisa, for this presentation. And so we've just shown you how we run the invitation workflow. So after this step, basically there will be a relationship, a trust relationship established between two nodes of the mesh, and the identities of the users on both sides will be known to each of the nodes. And from this moment on, we can start doing the actual magic and running the actual applications on top. And this is what we will see in the next two, in the following two demos. First, with Marcin, who's going to be showing the data analysis part, and then also with Ron. But
hello, my name is Marcin Sieprawski from Software Mind. A brief introduction. Data science environments are a ScienceMesh service which allows collaboration on Jupyter notebooks in a federated sync-and-share environment. For data science environment, we developed a JupyterLab extension which integrates with ScienceMesh interoperability platform over GDPR. Over gRPC, of course, and provides UI for sharing and collaboration features, replacing the original file browser in JupyterLab. We provide unified interface for shares. So this demo is based on local shares, but it would work the same with OCM. It basically build upon the trust that is provided by ScienceMesh, and make it transparent for users. And in this demo, I'll focus on collaborative workflows with locking mechanism, override protection, and how it prepares for future merge support. So the story for this demo is as follows. So Richard Feynman worked on some quantum mechanics stuff and collaborates with Albert Einstein. Richard created a Jupyter notebook, added his ideas there, and shared the notebook with Einstein using ScienceMesh data science environments. And they work on the same shared notebook. So Richard enters his JupyterLab environment and opens the notebook. He can add some code, execute, add some description formula, and also include interactive outputs. He can share this notebook with Einstein using either an icon that is in a file browser or the context menu. And in the share window, he can find Einstein by his first name, last name, username, or also by full email. Now, for the moment, he shares the notebook with the default viewer role, so Einstein can see what's going on, but the notebook is not changed. Richard can see the notebook, the share in the shares tab in a section shared by me. This tab is added in our version of the file browser. So now Einstein enters his environment. He can see the notebook in shared with me section. And since the notebook is shared with viewer role, the notebook opens in read only. So Einstein can change the notebook, but saving is disabled. So if he wants to save this, he can use save as, but as you can see, save notebook is disabled as well as the icon. And if he closes the modified notebook, the system prompts him to either save this as a copy or discard changes. So the changes are not lost. He can see the copy in file browser here. He could share this copy back to Richard to show him his feedback, but there's a better way. Namely, Richard can change the role of the share to editor. And he enters the shares window. There's a list of shares. He finds the share for Einstein, changes the row, and that's that. So now when Einstein opens the notebook, this will be in read-write mode. And now as you can see, the save icon is already active. He can add some note like I'll join your seminar in a moment, but first where's the tea, and save. And this workflow normally is sequential. So after some time, Richard opens the notebook in his environment and can see Einstein's contributions. So here it is. And now we want to see how it works when they start working in parallel. So let's see what happens. So Richard opens the notebook. He adds some additions. And he saves. In parallel, Einstein opens the notebook, and Einstein will get a window which informs that this file is locked. So he can choose either to create a copy and work on a copy, or work in preview mode. He chooses to work in preview mode, and again, this is read-only. The save is disabled. After some time passes, which is configurable, the lock expires, and now if this is the version that was in preview mode, but when he opens it now, it is already in read-write mode. So now he can add something to the notebook, save it, and this is active. So now Einstein doing these additions locked the notebook, and when Richard opens this now, in turn he gets the file locked window. So Richard chose to work on a copy, and this copy appears in the My Files tab. This copy is based on the recent version from Einstein, so he can see the stuff that Einstein added. He can add his contributions and save it to the copy. And in parallel, Einstein can add something else, but this copy is saved with the file name pattern, which allows to identify that this is a copy of this specific node, but it includes the original name, user, and timestamps, and there may be more than one copy. And when Einstein adds some new contributions, new content, this is obviously not synchronized with the copy, but Richard can open the notebook again. So here is the copy, but Richard can find the original notebook again, and then the file still is locked, but he can open it in preview mode. So he has two versions: his copy and also the file locked by Einstein, and compare the versions. And the planned functionality, this is the preparation for the future feature that when the system, when the lock is released, propose to merge the inputs. And when they finish that, they can share this notebook with a wider community and get some more feedback or contributions. So here is the link to the plugin. Tomorrow I have a talk on data science environments. I'll give you some more technical details about the locking mechanism and configuration. One of the benefits of this plugin is that the configuration with EFSS is very simple. And feel free to contact me because now we are preparing for deployment in CERN, and then we will be doing wider tests. So if you're interested, feel free to contact us on that. And at the end, I want to switch to the second slide. Just wanted to mention two more elements in the data science environment suite. So this is this, and yeah, that there are two more areas. I know that there was interest related to backend integration of the file system, so that the kernel sees the proper files for the notebook. So in some deployments, it is already solved, like Diogo explained yesterday in his Swan talk. But in some deployments, it has to be taken care of, and we have a demo for this, presenting two alternative implementations of synchronization and fuse mount for that. So this is one area. If you're interested, contact either Michał or me, so we can show you the demo for this. And second thing is the Voila and Voila library. You've seen the talk by Davide yesterday, and those elements are also part of this data science environment service. So at the end, Richard and Einstein could deploy a standalone application which would make interactive demonstration of their work. Thank you very much.
Thank you, Marcin. So next up, we've got Ron, who's going to be showing a demo on file transfers between virtual organizations.
Okay, well, good afternoon, everyone. What I'm going to talk about is data transfers, the work on data transfers that we've done in the CS3MESH4EOSC project. And well, this demo is mostly or predominantly about connecting existing research infrastructures with the ScienceMesh?
No.
Okay.
That won't work. It's my computer.
Okay, just there we go. Well, the past, what is it, 4 years or so, there was a project called Escape, and let's say it ended end of January this year, I believe. And well, the goal of this project was to address the common needs of a number of S3s and also other research infrastructures. People that, let's say, store and process data in a geographically distributed way. And there were a number of components produced by this project. I'm not going to list and explain them all due to time, but the most important one for this demo is the data lake. And yeah, the work we've been doing within this project is about data transfers, of course, but it's we distinguish two types of data transfers. One is the more long tail thing, ad hoc data transfers. So somebody is sitting at one sync&share service at his own institute and wants to, let's say, copy data to a colleague of his who has access to another sync&share service. And therefore, we have developed a data transfer mechanism based on rclone. We're not going to demo that today, but this is also what we worked on. What we are going to demo today is what we call the managed data transfers. And that's where you talk about the research infrastructures, the guys that distribute, who have distributed data stored at very different places, and are just organized scientific communities. And basically what we're doing here is connecting the big science with the user's laptop. Data transfer there. For that, we use the FDS, file transfer service. So it has been developed by CERN for the WLCG project. And basically that's a bash scheduler for data transfers. So you can submit a bunch of data transfers with source and destinations, and this service will just copy the data from one place to another. Okay, well, the use case that we had in mind is astronomy and also LOFAR. And the idea is that astronomers get bundle time on a telescope, then they get their, let's say, data package from those measurements. And they get to a place where they can pick up the data and share it with whoever else they want to share it with. That's also the gist of this demo. Here we have, in short, what it's all about. We have three storage systems. Two of them, the one in the middle and on the right, are sync&share systems, and the other one is part of this Escape data lake. And at the border, we have, let's say, a storage system, which is part of the data lake, but as well as also part of the ScienceMesh. The ScienceMesh that was on the right and the Escape data lake on the left. And we have also three people involved. Stella, that is the data manager who manages the data of that, let's say, telescope or other experiment. Then we have Jan, the primary investigator, that wants to have some data from this scientific experiment. And then there's Mirek, who is collaborating with Jan on the same subject, and both of them want to share data. And Stella is at LAPP, and Jan has an account on the sync&share service at SURF, and Mirek on the sync&share service at ChestNet. And what happens next is, well, Stella just instructs through the FDS let's say the data transfer from a lab to SURF. And this is exactly what happens here. FDS instructs the sync&share system at SURF to pick up the data at lab, and that happens here. And then Stella asks the sync&share service at SURF to share data with Jan. Stella has access to that system because she's also part of this distributed infrastructure with its own, let's say, federated identity management system. And her identity is mapped on a local user at the sync&share service at SURF. Then Jan, we're going to share this data file with Mirek, and eventually when Mirek accepts the share, he can ask his sync&share system to let's say, to show the data. And that's the moment that I'm ready for the video.
This one.
Yeah.
Spacebar.
Okay.
Wait, let me just turn off the presentation mode again. Is it on? Otherwise, people on remote won't be able to see it. You go.
No.
Not working. Nope. Same thing. Okay. Okay, yeah. Okay, we'll reshare whatever. Okay. Yeah.
There we are. Okay, it's our demo video. And here we have Stella, who wants to, let's say, copy through the FTS a file from lab to SURF. And well, apologies for the command line stuff, but it's the only command line stuff you're going to see this afternoon. So hereby, let's say, the FTS is instructed to copy a file from one place to another. And then that transfer is successfully submitted. What happens then is, well, you query for the status of that transfer. That happens here. And then you can see that the status is finished. So the file has successfully been copied, so which is good. So you can get rid of the command line stuff. Then Stella logs into the SURF EFSS and shares the file with Jan. Of course, this is GUI work, but in practice, you would definitely script this and do this through an API. But this looks more fancy. Well, here, this is a research drive instance of our favorite customer, Miskatonic University. We've copied the file to there. And here you can see it, that the file that has been copied is there in Stella's directory. And then she's going to share the file with Jan. So, and then Jan logs in and accepts the share from Stella. So Jan is then in possession of his data set if he accepts the share. And there it is. And now Jan is happy with his file. And now he wants to share it with Mirek. But he needs, of course, Mirek's EFSS and identity on that system. And to retrieve that, we have the invitation workflow that has been discussed and also demonstrated already. So we just skip this step. So we know now Mirek's identity and EFSS, and now Jan can just start up the ScienceMesh app and see if he can find Mirek among his contacts, which he can. And then he can share the file with him. And that is what is happening here. Now, Mirek is going to accept the share, and then Mirek can just do with the file whatever he wants. And that's what's happening here. The Mirek at the Chestnut instance accepting the share. No, and that's it. Thank you.
Thank you very much, Ron, and thanks to all the presenters. So at this point, I think we have some time for questions. So I don't know, what did you think about the demos? Do you have any, are you curious about anything in particular? Any comments, ideas? Yes, one over there.
This is more like generic for all today's presentations. I've seen how you create the shared and federated access and group sharing and things like that. But whenever you want to delete the share, who has the right to delete the share? Is it the one that you invited to your share, or is it just you, or is it have to happen on the first node on that federated environment? Or so I think that that's one important demo that we should see at least at some point for scientific people.
Who wants to take this one?
I can take it. Is this on? Yeah. So there are two ways to delete share. You can actually delete the resource, or you can just unshare it. And deleting the resource, the sender can do that, obviously. Then the receiver can also do that if they have a read-write share. So depending on the permissions they can, if it's read-only, then they cannot delete it. And then for unshare, they can also both do that. So you can, the sender can right-click and say no longer be sharing, and the receiver can do the same. And then there's a notification so that the sender actually knows that they stopped listing the thing you shared with them. But it's a good question. And for the invites, that it's a similar thing. So you invite somebody to become a contact, and then you're connected and they show up in your contacts. And there's actually an open issue to still add a delete button there. Now that the invites are two-way, we also need to handle, like, if I delete you as a contact, then you should also see me disappear as a contact probably. So for the shares, it's all implemented, and for the contacts, it's an issue we've got planned.
Okay, one more over there. Is it on?
Oh, okay, no. So from the point of view of application like the Jupyter plugin, we connect to the API. So in this shares window, when you find the share, you can delete it. There was X sign, so we delete it. And also this is also visible in Reva or EFSS. So somebody else also who has any rights can manage that like that. But from the point of view of user who shares something, you have a list of shares, and you can like change the role or also delete the share. And from our point of view, it doesn't make any difference if it's OCM or local share. Like so we find the share, delete it, and this is sent over the API to interoperability platform.
Okay, thank you.
Hi, I have a question that we haven't come across yet. It's a user, it's a very recurrent topic, and a user coming asking us that he wants to share some data with someone else that has no account anywhere. So in previous times, we were doing it in FTP, but this is not considered secure anymore. And it was easy for the user to request an FTP account, even anonymous account. And it was programmatically accessible via console, or even web browsers were supporting it, or graphical user interfaces. So nowadays we don't have a solution for that. And is there something that would you suggest?
I have the feeling Ron or okay. Do you want Ron or Milan? I don't know who wants to take that one. Or I guess.
Complementary. Okay, yeah, we have also this use case which we have to address. We call it ScienceMesh space, let's say, for homeless users who really wish to participate. However, their organization or their home institution cannot, for some reasons, be connected to the ScienceMesh. So we will probably participate with UDAT in this manner to utilize the B2 drop, I believe it's the name of the service, where we can provide the accounts for the homeless users, and this B2 drop instance will be also interconnected to the mesh, so you can also establish the federated sharing for this purpose.
Yeah, great. Thank you.
Okay, guys, thanks for the presentation. I hope my question is not a very dumb one, and maybe it's already been answered in the several slides. But the invitation workflow and building the trust relationship, it starts with receiving an email, right? And we all know about phishing. So sometimes I may get an email that looks very much like someone I know, but not quite. So how is this covered or handled? Is this via the directory, or is there any chance of like a bad agent injecting himself into the system in that way?
I don't know if anyone wants to take this one. I would say it's not necessarily via email. I mean, what you basically have to send to the other person is a token normally integrated into a URL, so you could share it through a safer means of communication, like end-to-end encrypted channel, something like that. I don't know if anyone wants to add to that.
Yeah, well, the mail gets sent to you by someone you know, so.
Yeah, that's
or someone who might, yeah.
So even if I pretend to be whoever your boss or a customer or somebody important that I'm not, and you believe that the email is really coming from then the token of the invite is a long string, and it's checked when your server connects to my server. So it would just fail to connect. The URL contains a provider domain, which I could still put in, like saying, hey, this is coming from CERN. And then the first is there's a where are you from, so that you make sure that you can log into your site first. And then your server will talk to the CERN server. And so I can make that happen. I can make you tell your server to talk to the CERN server, but then the CERN server will say no, because it doesn't recognize the token in the invite token.
Of course, if the problem is someone forging an email with a ScienceMesh logo and a link, God knows where to, I think there is absolutely no way we can fix that in a practical way.
No, even if the email looks legit, then it will try to establish this connection. But then because you could never have the token is secure.
Sure. No, but I'm saying if the link points to a malicious site, that downloads ransomware or whatever. That's a problem that every platform I know has, right? It's
If I can add to this, the reason why we have this directory of sites is precisely to have this extra level of trust, which would be a bit of an addition compared to the standard of CM sharing, where indeed, otherwise, how do you trust that the other guy is who pretends to be? The directory is there to have this extra level of protection. Modulo what Pedro mentioned, of course, it's still a link.
So you have to check that it's the proper link. But it's obviously a link that points to the mesh directly. That's the idea.
Any other questions? Well, if not, I think then let's thank the speakers once again, and thanks everyone for coming. And I hope that that you've enjoyed this series of demos. And I believe we have a coffee break now, right? Do we have any announcement? Yeah.
So hi there. My name is Javier Ferrer, and I work at CERN. I want to talk about the work I've been doing for the last couple of months on our EFSS, which is CERNBox. It has been already properly introduced by my colleagues before, so I'm going to focus on the data that is relevant for us, which is collaboration. We have about 300,000 shares right now at the moment, and I think it's 200,000 of them are public links. So it's being used heavily as a collaborative suite too. And since the release of the 2.0 version, we've had a lot of requests like the ones that are shown here. For example, the first one, which is the one I'm going to focus on in this talk, but they all point to the lack of a very important feature, which is a notification system. So this is what I've been implementing and what I'm going to talk about. From a user standpoint, what we want is it to be usable and very simple to, very intuitive. So if we go back, if our occupational health service user, which is Alice, wants to publish a public link folder for other users to upload stuff to, and she wants to get notified, the only difference between the regular flow would be that she will have to click on this new checkbox. And then when Bob, which is the user who is uploading a file to the drop zone, does it, she will get an email. So it's a minimal change, but it provides a new feature. But now, from a developer point of view, we want a flexible, scalable, and reliable notification framework. Because in the end, Riva and CERNBox is in continuous development, and we want to add more stuff to it. So it has to be easy for developers too. I'm going to explain the mental model first, because this will help us later to understand the layer architecture that I've designed. So, and I'm going to start in the middle. In the backend services, we will be registering templates into a notification service. And these templates will have a handler, which is the thing that is in charge of actually sending a notification, for example, an email handler, for our example. Then a user can register notifications in our service, which will later be executed by triggers, which would be the thing that will be caused by Bob, by uploading a file. Okay, so now we have this architecture where we can see our Riva backend. This will be the web, the front end, and Alice above. I'm simplifying the backend. There's only some relevant services and our new notification service. Here, Alice is sharing a folder by using the web, and it goes to OCIS and creates a share. And then Bob uploads a file to this public link by using OCIS. So how do we connect this to the new notifications service? We've been evaluating different choices, because we don't want to expose an HTTP API for the service, because it should only be talking to the other backend services, because they are in charge of actually generating the notifications, not the front end, for example. After looking around, we decided to use NATs by multiple reasons. One of them is that it's already been used in Riva and OCIS, as well, you know the difference now because Klaas explained it in his talk. But another very important reason is that besides having a Go client, which is what the backend is implemented in, it's very easy to get started with. It guarantees exactly when there's delivery, even if the receiver is not there yet when the message is created. And this is very cool too. It provides a key value store, but it's a very it's an implementation detail, and you can come to me later and I will explain it to you. So back to our infrastructure. Now we have this here, the new NAT server, and we repeat the same flow as before, but well, no, sorry, one step before. On initialization of Riva, all the services register the templates through NATs, which is sending the messages, gathering the messages and sending them to the notification service. Then we go back to our flow. Alice shares a folder, but this has an extra step, which is OCS talking to the notification service through NATs to register this notification when she clicks on the checkbox. Then Bob uploads his file, and this has another extra step, which is OCS talking to NATs and then to the notification service, sending a trigger, which is the actual event that causes the notification server to process everything, all the data, generate a new email through the email handler and send it to Alice. Okay, so developers wanting to use this in a new, I don't know, a new service back in Riva, or maybe even an external service which can talk to NATs without using Riva because it's an exposed server. There are some questions that might come up to mind. The first one is, what if somebody decided to drag and drop 1,000 files in one go into the drop folder? Do we get 1,000 emails in 1 second? So this is covered by the bouncer that is implemented in the service, which will aggregate the relevant triggers that have the same identificator. And it is in charge of waiting a timeout and then aggregating all of them into one, which is the one that will be executed. It also extracts some information from the triggers, so it generates a small an aggregated record with the first entries if it's very long, and some information about the count of entries. So even using the same template that you're using for a single notification with some conditionals, you can use the same one for single and multiple notification triggers. And then another question is about debugging, because this seems like a complex setup. So the first step, there are 3 steps, but the first one is always the logs. The logs are very rich, and you can see how the handlers are initialized, the notification server is connected to NATs, the templates are registered, then a trigger, a notification is registered, then a trigger is sent, how the accumulator works, and how the message is sent. So it's all there to debug every step of the process. The second step would be go to the Riva CLI, where we've added some commands to work with the notifications and the triggers, to delete the ones that are pending, create new ones, trigger a notification. And then the third step, if you want to go even deeper, is to go into the NAT CLI and take a look at the channels and the streams, which will require some knowledge of NATs, but it's very simple to get started with. So this can be like a last resort if nothing else works, which shouldn't be the case. This is all. Now, for the future, because there's a lot of stuff that still can be added to this, the first would be to publish the notifications API to the CS3 APIs. For this, I'm asking for help for somebody who is more familiar with them, because I'm new to this. Then another step, of course, is to add more handlers, so you can send a notification to the sync client, into Mattermost, to an SMS, for example. And we also have web notifications, but it would be good to have a full-fledged notification center in the web that is more advanced than what we have right now, which is only a small pop-up with a notification. And this is all. Thank you very much. And if you have any questions.
The next speaker is Marcin. He will tell us about data science environments in ScienceMesh. Welcome him.
In that direction, yeah, here. Okay. Good afternoon. My name is Marcin Sieprawski. I lead Big Data Lab in Software Minds, focusing on data-driven innovation and data science. I'll present JupyterLab plugin connecting JupyterLab to ScienceMesh. I've already yes, and this plugin is developed by my team at SoftwareMind with close collaboration with CERN, with design and coordination by Diogo Castro. In that direction, yeah. So I've already presented the user journey for this plugin yesterday at ScienceMesh demo session. So if somebody hasn't seen it, you can just visit these recordings of this session. Now I'll just quickly recapitulate some main points for this. This, yeah, okay. Probably I could skip this slide, but for order, we built this system upon the federated sharing in ScienceMesh. You've seen yesterday the invitation workflows. We basically don't necessarily care how it works. We just take it for granted and use it. And we are one of the applications that can be used in a federated manner. So the idea is that the plugin integrates with ScienceMesh, with CS3 APIs, with gRPC, and we replace the default file browser, adding some functionalities for collaboration and for sharing. And we based this, the federated sharing is based on the unified shares interface. So basically, users don't care if we use CS3 or OCM. In the demo yesterday, we used local shares, but it will work the same with OCM. The focus is collaborative workflows, and I want to show today quickly the configuration, how you can easily configure it with the EFSS. Okay. So here, sharing functionalities, the icon and the share file item in the menu. In the shares window, you can select the users by first name and last name, well, by part of first name and last name, and using full username on email, you can also find the user. And based on this, if the user is in another system, it will be OCM will be used, and you can select viewer or editor role. In the added in our file browser shares tab, you have shares shared by me and shared with me sections, and also currently it is not in this workflow, it is not used, but we also implemented possibility to accept shares if this is necessary in the sharing workflow. For locking mechanism, if the file is locked by another user, which happens basically by opening and saving the files when one user works on it, another user gets a file locked pop-up with two possibilities to work on a copy or work in preview mode. And in preview mode, as well as in the viewer role, we implemented read-only accessing of notebooks, which means that you can make some changes, but you cannot save these in the same place. You need to use save as to create a copy. And also, if you make any changes and you close the file, the system prompts for saving it as a copy. With regard to locking mechanism, when we implemented the first prototype for locking mechanism in the plugin, there was no lock support in CS3 and Riva. So one implementation is based on CS3 API's metadata support. So the lock object is in arbitrary metadata containing user information and timestamps for the logs necessary for timeout for expiry of logs. And now, since the new locking functionality is implemented in CS3, we use the existing locking mechanism in CS3. But the first option is also still available, and you can configure use to one or another, because in some systems locking mechanism may not be implemented. So then you can use the metadata-based locking. Speaking of configuration, this is a default config file in the system. When you have configuration for Riva connections, authentication for clients, and also some additional parameters like log expiration time. You can enable or disable OCM, specify kernel path, and for running this in a cluster for Jupyter Hub for spawner, you can specify those parameters in environment variables. And all we do, we don't. This is not something that happens only on the Jupyter part. Everything we do happens in EFSS, or in this case in Riva. So as you can see, the files that were created in the demo are in Riva. And also, as I mentioned yesterday, the shares are managed by the user in the plugin inside JupyterLab environment. This is the idea that the users can do everything in JupyterLab. So that this is the idea behind JupyterLab, that this is fully fledged environment for data science activities. And we are not embedded in some system. We added sharing and collaboration functionality to JupyterLab environment. So if we share some file with somebody, we can also, using the share windows, access these and basically remove the share. But if administrator wants to manage those shares, it can be done on the level of Riva or EFSS. Probably I don't have to explain the benefits of sharing and collaboration in data science. Some time ago, it was like solitary superhero stuff. Now the projects are bigger, and collaboration becomes really crucial. I also want to mention again the other activities that are connected with this work together with this plugin. So we have prototypes for integration or with file systems, either synchronizing or based on FuseMan. But this is actually also area that probably will be some area of future development. We think that there will be much more options in the future for developing how the kernel can use, and what will be the policy for synchronizing, sharing, or metadata-based access to data. And another aspect is deployment of interactive dashboards. So here I updated the new name and logo of Voila library Davide. And you can visit GitHub to get this. This is open source, and we will be now deploying this solution in CERN, and next couple of months we'll be doing tests with other deployments. So if you're interested, please contact us. Also, if you're interested in this area, we'll be happy to join any projects or efforts that will continue this development of those solutions. And that's that. Thank you very much.
Well, the interesting talk. Are there any questions from the audience to the speaker? Here comes Kuba, the next speaker. He will summarize and let me say, or also conclude this part of the workshop so far. And are you ready, Kuba?
Does this work? Well, what can we say? Congratulations, you've made it thus far, 3 p.m. on the last day. I think this is pretty impressive to see so many people still hanging around. Yes, a couple of words. And some closing remarks. So first of all, you know, as any successful project or activity, it all boils down to people. So this is the set of people that have put quite a lot of effort into organizing this. So please, a round of applause to them. Especially Gideon, who is our local or main coordinator for the local organization, who really has put enormous effort into making sure that everything worked out so perfectly. So thank you very much, Gideon. It's really great job and appreciated the collaboration with you. Next, big thanks to our local organizers, ESADE as an institution. They've not only provided us with this very nice venue, but also with very good weather in Barcelona. I'm pretty sure that was all arranged. And I think, you know, this is one of the best CS3 events we've had. I think everybody can agree to this. So many thanks. A couple of thoughts I just wanted to share because I discussed with several people, but this is essentially an open discussion. So if you do have some other ideas, you know, we can take a few minutes to share them and maybe discuss. So one reflection that was made is perhaps, which is an old new idea actually, is to have a session on user stories and requirements and specific research infrastructures. Because our conference is very much focused on technical aspects, which is very good. We also have a good diversity, right? Everybody agrees. There is some very detailed technical talks. There's also some much more overview, high-level talks. So this is a variety which is greatly appreciated. And I think this is what makes really a kind of a unique, is kind of unique for this conference as well. But I think perhaps a component that we would be worthwhile adding is having users or representatives of the users more prominent at this conference. So maybe a session or two on people coming and explaining what they are trying to do in their research, what are kind of challenges and needs they have, and possibly if they are using the services that we offer in this community or not, and why yes, why not. I just wanted to exchange with you what you think about it, because from my point of view, that would be something interesting. And if you share this reflection, then I would like also to ask you to help make it happen at the next event. So if you have some connections to user communities that you think would be worthwhile to invite to this event, would be interesting.
Thank you. Please allow me to look at the whole conference as a bit of an outsider. Thank you for inviting me. I really enjoyed giving the keynote and get a lot of interesting discussions afterwards. So there's two things that I would like to bring in. First, building on what you just said, I see a little bit of the same as what I see in EOSC as a whole. The whole idea that we need to engage users in the EOSC has always been alien to me from the beginning. But if you make something that researchers really need, you don't have to engage them, they will join, you know. So I see here a little bit the same thing. There's technology-driven people making beautiful stuff, and then they start thinking, oh, maybe we should invite some users to see whether they actually need this. So maybe in the future, you should really get users in to say, okay, what do we need? And one, that is my second point, as a user, I see all these beautiful things that I saw in the last few days. But as I said on day one, they're all directed at people. We even have all kinds of tools to make sure I'm not a computer. Please tell me all the pictures that contain cars, you know, all this kind of stuff. While my vision, as I said in the keynote, for the future is that the major users of our systems in the future are machines, not people. People may instruct the machines. So I would like to see everything I saw during this conference, but then adapt it for the actual independent use of machines, of course, with people in the background. Huh? So maybe invite some machines next time, you know.
Okay, that wouldn't be a problem. Thank you very much for sharing, and I definitely agree with what you said. I think the structure of this community, this remark is mainly for the event itself, because the structure of this community is that many participants here represent a service that is heavily used in their local user communities, or in their, you know, with different disciplines and so on. So I believe, of course, it's a completely rightful remark that, you know, users drive the requirements. What I believe is maybe to be improved for this event is to invite, to have more presence of these, of the users in this event, because we have a very, I think, very, let's say, beneficial exchange between the technical people. So there is, you know, how to improve the service, how to run it better, more reliable, whatnot. But probably also at the level of understanding the requirements in other communities that I do not have access to so easily from my local perspective could also be equally beneficial.
What you also have to think about is, you know, I'm now talking as a proverbial stupid biologist. Whenever I see code on the screen, I run away. Yeah? So, I mean, you want to have the nerds to talk to each other on technology, and they love to see all the code and stuff like that. And maybe you run away when you see my first, you know, slide on genes and diseases. So when you organize a meeting with the users, that's on the one hand very good. Let me share a very old experience in 2015 when I was chair of the high-level expert group for EOSC. We had to prevent one user from showing a slide that the only way to make EOSC ever successful is to exclude the e-infrastructures from day one, because they have been building all this stuff we don't need. You know, that was his slide, not my words.
So there is this continuous tension between technology-driven people that think that we all love what they make, and we say, no, we won't never use that, you know. And so we are in the midst of trying to get what I call EOSC back on track by saying the research communities have their own tooling and their own stuff that they build, analytical algorithms, file storage, whatever. Unless you open up EOSC to be a web of fair data and services where people can plug in their own, you know, proven technology, it will never get anywhere, and you will be spending 3 more years user engagement. I hate the term. You know, if you really build something that we need, we will not need any marketing to engage, you know. So, but on the other hand, don't expose biologists for 3 days to the sort of stuff you're discussing. We will just be completely bored. That is a dilemma. So maybe parallel sessions where you bring, you know, users together with providers without going into the deep technology behind the screens, you know. So you really get to understand each other better. And I'm not saying that any of the stuff you showed today will not be used, because you already have a lot of users. That's a big difference with many other things I see. But I think getting this as a real service to research and innovation, you need to involve people like me saying the sort of data we produce cannot be handled by people. We need, as Alfonso showed and as I showed, everything that you plug into the wall is now spitting out terabytes. So having a file system for stupid PDFs is not something I am interested in at all. I mean, we can do it, but that sort of future developments and many of the things you showed today with maybe some minor glitches can be totally useful for machines as users. You know? So that could be a nice topic for the next meeting, maybe.
Yeah. Thank you.
Actually, I have a different view because to me it looks like this, because I'm sort of outside of this community of people who provide this infrastructure, and it looks that it makes sense to organize it in a way that there is a group of people who takes care about how this technical stuff works, and to do it in a way that it's possible for people like me to provide some applications to basically connect to API and do something on this for people who totally don't care what happens underneath. They need to share a file, and that's simple as that. And to make it happen, there usually needs to be an army of people who takes care that this magic happens. So yes, we should think about what users need, but there are technical details that need to be taken into account. So
yeah. Well, thank you for sharing. Again, I say that I think from my perspective, this community does not have a problem of not having users. So I think there's 400,000 at least, or desperately looking for use cases, as some of the initiatives, European initiatives that have been mentioned before. But I don't know, but I think it's also something to reflect about, these 2 comments for the future. Any other reactions, opinions, ideas? Then there were also during some informal talks, there were a couple of points of interest that were apparently manifested. So there is some interest on Riva and CERNFS. So maybe Hugo can talk about this more, because he had gathered quite some feedback from the community. Of course, about federations, so there were some questions how people can join. Can I join? What can I do? Also, some funding opportunities for community projects or next projects were discussed. Is there anything else that you would like to bring to the table that you saw as an interest, emerging interest, discussing with people? So maybe Hugo, do you want to say a few words about the interest on the first point?
Yeah, so regarding the Riva FFS, basically the problem that we would like to try to address here is the following. How many of you run sync and share platform that owns terabytes of data by Apache? Yeah. Don't be shy. Don't be shy. And another use case is that we see basically a discussion today with the community that there are institutions providing services for sync and share. So there is a very dedicated service for sync and share, but then there is other service, for example, dedicated for high throughput computing or for HPC. And I see that there is a need basically to merge these two communities. We have done this with CERNBox in the past, with EOS is basically what you saw there, but we are also looking into doing it with FFS. So we are committing to do this for us, for SEM, because we need this integration. However, we would like to bring this know-how also with your input. So I'm calling basically for people, for institutions that would like to contribute to this development, also for institutions, companies that are interested into this. So now is the good time to stand up and show your interest for this interest group, so we can have a further up discussion after the conference. So who is interested? You want to speak, Gonzalo?
I hope I understood the question, but yeah, from the things that we've been talking these days in the coffee break and so on, definitely. I mean, I didn't raise my hand to your first question, so I'm a novice here in the sense that we are not running any sync and share or so, but we are totally interested. I mean, we are let's say a science data center in that we serve big scientific experiments. So we have a lot of data, a lot of, and we are. For us, the killer app somehow, or the killer feature, is this connection. We totally need this connection of the sync and share with the actual file system ownership and so on. So in particular, looking into the Ceph technology. So that developing that feature in the Ceph ecosystem is something that looking forward we'll be interested in, definitely.
Awesome. Okay, so we will basically maybe send a survey to see basically who will be interested into participating into this, say, working group task force, and maybe in the next conference we will have something to show up.
Okay, so people interested in this, just contact Hugo, and people interested in Federation, in particular in ScienceMesh, just go to the project website, and then you can contact, get a contact there. Okay, last call for any additional topics of interest.
Well, maybe just to remind on the federation part, I see also some interest in having a mini OCM workshop, which could be probably even online, or we do it at CERN, to be seen. But I mean, this fits kind of with the federation, but not precisely with ScienceMesh. This is really more for the OCM implementations to align everyone.
Definitely, I think this is a very good idea. As always, there is a question, who drives and who hosts this kind of initiatives. So in the last 3 years, we have been trying to host it through the EC funding a little bit and give it a little, to maintain the momentum. But I think also some other ideas or some other contributions from or participation from the community, and especially maybe also the vendors who are essentially implementing this standard could also somehow look into this.
Yes, I think if we're a group of individuals who want to contribute to this, then we could get some NGI funding, for instance, as a quick way to fund ourselves to work on this with everybody who wants to put in some time. That would be one way to do it. Whoever wants to help work on open cloud mesh, we can just get together and see how we do it.
Very good. So we have also contact point here.
Yeah, I'll be a contact point.
Okay, excellent. Any other ideas? Okay, just a small reminder, we've just opened the conference feedback form, so please take a few minutes and give your feedback. It would be very appreciated. In case you have any other further communication or questions regarding the event itself, or maybe some topics that have been discussed now, this is the email address. Thank you all for participating. It was really great pleasure to see you again in many cases, or for the first time in many other cases, in person, not on the screen. I really enjoyed this, and I hope it was equally enjoyable for you. And thanks a lot for your contribution, and enjoy the rest of the day, and see you at some other point. Right.